Back in the 1950s, the engines that powered a Formula One car produced around 100 brake horsepower per litre. That's about the same as today's performance road car. Back then, there was a lot of room for improvement. By the late 70s, the new turbo engines were capable of nearly 1,500 brake horsepower. That didn't last long, though.
In 5 years, you have a very, very small engine with a lot of power, and it was maybe more exciting. But the people decide, the regulation decide to coming back, especially with the power, because the car was very, very fast on the straight line.
In 1989, naturally aspirated engines became mandatory, and since then the power output of the F1 car has been heavily regulated, making the performance of the car's other 4,500 components increasingly important. Every aspect of the car's construction and design is subject to hundreds of hours of testing and development, with roughly 25% of the F1 car made of some kind of metal.
On the metallic material point of view, we are using more than 100 different alloys. Typically aluminum, copper, titanium, cobalt, tungsten alloys are used. There is a standard to mention, is aerospace standard we are using. But a lot of material are developed with some suppliers. And we can develop our own standard with them. But typically, if you have to mention a standard, these are aerospace standards.
The manufacture of these parts is all undertaken in-house at Toyota. Exhaust pipes, for example, are created by hand. It takes a technician around 50 hours to complete a single pipe, and each set of pipes lasts just one race. The other 75% of the car is made of carbon fibre. Strong, light and easy to work with. The machines in Toyota's F1 factory are able to design the smallest of carbon fibre components to an accuracy of 4 microns. That's about 25 times less than the width of a human hair.
15 years ago, no Formula One team had its own material department. Now we have a very advanced material department. We can perform analysis in our buildings. In the past, every Formula One team relied on external labs to do mechanical characterization of parts, material consistency. Now everything is done in-house because you have to move in-house the material expertise to have quality on the end product.
F1's evolution no longer consists of huge leaps forward, but rather small engine adjustments and design changes. That endless search for tenths of a second at seemingly any cost, which defines the grandeur of Formula One.
We are not changing materials a lot, we are developing them during the season. So it's difficult to judge how many materials. It's a continuous evolution. We are constantly developing materials to improve performance of future parts to be designed.